Welcome to the 2025 AIME 1 problem series. In problem 7, it gives us that the 12 letters A through L are randomly grouped into 6 pairs of letters. The 2 letters in each pair are placed next to each other in alphabetical order to form 6 two-letter words, and then those 6 words are listed alphabetically. For example, a possible result is this sequence. And we want to find the probability that the last word listed contains a G. Okay, well, this result, in this result, the first letter of each word, of each two-letter word, form in alphabetical order, and in each of the two-letter words, the letters are arranged alphabetically. So, in order to calculate the probability that the last word contains a G, we will do cases. So, in case 1, G will be the first letter of the last word. And in case 2, G will be the second letter. G is the second letter. Okay, well, let's consider the case when G is the first letter. So in this case, if G is the first letter of the last word, then each of these blanks right here, 1, 2, 3, 4, 5, have to be occupied with 5 letters from A, B, C, D, E, or F, since these need to be listed alphabetically. So there's 5 blanks, but we have 6 letters. So obviously there are 6 different ways to choose which letter to leave out. Well, the problem with doing this and multiplying by the total number of combinations is that depending on which letter we leave out, there actually may be different total numbers of combinations. So, say we are to leave F out, and the first letters are going to be A, B, C, D, and E. Well, F definitely cannot go in this last blank, so it has to go in either one of these 5 blanks that happen to be the second letter of the first 5 words. So F has 5 choices if it's left out. Well, now consider if we are to leave E out from consideration of being the first letter of the first 5 words. Well, if we are to leave E out, E can't go in either this spot or this spot. It won't work. So E has to either go after D, C, B, or A, giving it 4 choices. And we can do the same thing for when we are to leave D out. So if we are to leave D out, well, D can only go after C, after B, or after A. So that gives it 3 choices. Similarly, if we are to leave C out, then C can only go after B or A, giving it 2 choices. And finally, if we have to leave B out, well, B can only go after A. So that gives it 1 choice. And obviously, we cannot leave A out because that would mean B is here, and A obviously can't go after any of these letters. So this is the total number of choices that we have. So there's 15, 5 plus 4 plus 3 plus 2 plus 1 equals 15 different ways that we can arrange the first letters of each word, considering that G is the first letter of the last word. Well, in that case, now we have to decide, well, for each of these 15 ways to do it, how many ways can we arrange the remaining letters? So we've already used all the letters from A through G, since after considering the first letters, when we also take care of the letter that we left out, we are left with the letters H through L. Well, the number of ways to arrange H through L is just 5 factorial. So for example, in this case over here, where we leave out B, we can choose if we want to put L here, K here, I, J, or H. And that is one of 5 factorial combinations. So that's why we do 15 times 5 factorial. Now, 15 times 5 factorial will give us our total for subcase 1, or for case 1. 5 factorial is 120, times 15 gives us 1800. So that is our total for case 1. Let's look at case 2, where G is the second letter of the last word. Well, in this case, we need to still arrange the letters A, B, C, D, E, and F. Well, now notice that there's 6 opening blanks for each of the six two-letter words, and all of these are the first blank of each of the two-letter words. So therefore, A, B, C, D, E, and F must go in these blanks. Because if not, then it would break the alphabetical criteria since some letter before G is going to appear, or some letter after G is going to appear here. So that isn't possible. So these are the only ways to arrange the letters A through F in this case. And then obviously we have to arrange H, I, J, K, and L. That's a total of 5 factorial for this case. So we end up with a total of 120 for this case. So in total, from case 1 and case 2, we have, I'm gonna make this, so from case 1 and from case 2, we have a total of 1800 plus 120, or 1920 ways to do this. Okay, well, what's the denominator of our fraction? How many total ways are there to actually do this? Well, let's go back through seeing how we can construct these. So first of all, the two letters out of 12 letters are grouped into pairs. So as we know, this is the same thing as doing 12 choose 2 times 10 choose 2 times 8 choose 2 times 4 choose 2 times 2 choose 2. That's the number of ways to select 2 letters at a time from these 12 letters without replacement. Now, when we get each of these 2 letters, this dividing by 2 by the choose 2 symbol indicates that there's really only one way to order them, which is alphabetically. So that takes care of the case of ordering the letters in each word. Now, what we do have to be careful of is actually making sure that there's only one way to order the words themselves. Well, since there's 6 words, there's going to be 6 factorial ways to order the words, and we can only count one of them, which is the correct alphabetical way. So this is going to be our total denominator after dividing the product of the combinations by 6 factorial to account for this. Okay, well, instead of actually bashing it all out, we know that 12 times 11 over 2 is the same thing as 6 times 11. We know that 10 choose 2, or sorry, we know that 12 choose 2 is 6 times 11. We know that 10 choose 2 is 5 times 9. We know that 4 choose 2 is 4 times 7. Then we know similarly 3 times 5, right? Or 3 times. Mm, oh, yeah, here I forgot about 6 choose 2. 6 choose 2. Yeah. 12 choose 2 times 10 choose 2, 6 choose 2, 8 choose 2, 4 choose 2, 2 choose 2. Yeah. So we're going to end up with 3 times 5 times 2 times 3 times, and then 1, obviously. Okay. And then we divide this by 6 times 5 times 4 times 3 times 2 times 1. So by the way, this is our total denominator. So here 6's cancel, 5's cancel, 4's cancel, 3's cancel, 2's cancel. And so we're left with 11 times 9 times 7 times 5 times 3. And so that is going to give us, I believe, it is going to be, I don't remember exactly. So we have 3 times 5 is 15, times 7 is 105, times 9 is going to be 945, and then 945 times 11, same thing as 945 times 10 plus 945. So it looks like this should be 10395. Yep. And so this is our numerator, this is our denominator, and so our answer, not reduced yet, is going to be, let me make this smaller so we have some room, is going to be 1920 over 10395. Here, it may not be entirely obvious what to divide it by, but it is quite obvious that we can divide both top and bottom by 5. So we have 2, I think it's 2079, I believe. Yep. And then on the top, we should, when upon dividing by 5, 1920 divided by 5 gives us, I think it's 384. Pretty sure that's what it is. Yeah. And so here, 2079, the digits add up to 18, so we know it's divisible by 3. We can go ahead and try dividing by 3. On the top, if we divide by 3, we're going to get 128. On the bottom, if we divide by 3, I believe we're going to get 693. Yep. And so this is our completely simplified fraction. So now we just have to add the numerator and denominator, and we are going to get our final answer of 821. So there it is. That is the 2025 AIME 1 problem 7. Thank you for watching and please subscribe.